right, let's do some Mathity-Math. All right, we got a big story problem here. Before we get started, I do want to encourage you guys to not freak out when you see these large story problems, and just remember, we love stories. Movies are stories. Books are stories. So we should take a chance to realize that we do enjoy these things, and they don't have to scare us away. Remember, we're going to take it step by step, bit by bit, like cutting up a pizza, and we'll go from there. So here we go. It says, you are skydiving, and as you fall, you see your pal Roscoe. Unfortunately, Roscoe does not have his parachute. Typical Roscoe. All right, being the good friend you are, you grab Roscoe and latch yourselves together. Well, that was nice of you. Now, you weigh 75 kilos. I'm going to go ahead and highlight that. I think I'll need that. I weigh 75 kilos, and Roscoe weighs 13 kilos. Okie dokie. But your parachute can only hold 90 kilos. Okay. While you fall, Roscoe informs you that his pockets are full of very heavy gold coins. Okay. And you calmly ask Roscoe, Roscoe, how many gold coins do you have, buddy? Roscoe replies, I don't know, man. What I do know is that I weighed myself before I jumped out of my plane, and I weighed 35 kilos. Okay. With all my gold. So 35 is all his gold. Okay. And I know that each gold coin in my pocket weighs 1/3 of a kilo. Okay. So you inform Roscoe that he needs to get rid of some of his gold coins. All right, let's get this thing going. So if you think about it, we got two sides to this story. We have the side over here. This is what the whole group weighs. This is what we weigh. Over here is going to be what this parachute can safely hold. So we know the parachute can hold 90 kilos. And if we really think about that first, before we do anything, whatever is over here, if it is bigger than 90, well, the parachute breaks and tragedy ensues. But if everything over here is smaller than 90, we're safe, right? So whatever happens all the way over here, we want that to be smaller than 90. And I guess technically, if you want to push it, we could say it could be equal to, but you know, you're flirting with disaster. But it's a math question. We can let it slide. So let's just break down this story. Let's talk about the weight of me, the weight of Roscoe, and the weight of gold. And starting off, let's go ahead and do that by keeping them all separate, right? So I know that I weigh 75. Okay, that's how much I weigh. And I know Roscoe weighs 13. Now, you gotta be a little careful here. You might want to write down 35, and you could, but then you can't write 13. Because this 35 is Roscoe and the gold. But what I want to do is I just kind of want to write down just what is happening with the gold. So what is just happening with the gold is the total weight minus Roscoe's weight. So 35 minus 13 is 22. Okay, so we know that the gold weighs 22. And what I'm going to do here, you don't have to do this, but it helps me kind of keep my ideas separate here. I'm going to kind of put the gold part in parentheses because the gold can actually go down, right? It can go down because we're going to tell Roscoe to throw out some of his gold coins, okay? So when we look at this, if Roscoe's going to drop some of his gold coins, we don't know how many, but we do know that each one is worth 1/3 of a kilo. So we're going to subtract 1/3, and we can write that as X. And the X is how many coins is Roscoe going to drop? Well, I don't know. We're going to figure it out. You better drop some. Otherwise, we're in trouble. So here we go. We got me, we got Roscoe, and we got the gold and what we can take out here. And I like to separate this because we can't throw out more gold than we have, right? So this will help constrain the gold, right? I can't like just throw off pieces of me or pieces of Roscoe. We only throw off pieces of gold, okay? So what this means is these things are locked in, so we can't combine those like terms. 75 plus 13 is 88. So I think a good answer for this one, we can say, well, it's like saying 88, that's me and Roscoe, plus the gold, plus the potential of losing some gold because we want to save our lives. This all must be less than or equal to 90 kilos. Now I'm going to box that up. I like that answer a lot. And I should be proud of this answer, so I'm going to put a frame around it. Now, I like to frame answers up like this and leave it like this because it really does help us conceptualize what's happening here. You see, if I know me and Roscoe are 88 and we got to be under or equal to 90, well, we know straight away that we got to get down to 2 pounds, right? That's what, or excuse me, 2 kilos. We got to get down to 2 kilos. This gold has to be 2 kilos. So if we can make that connection, this gold can only be 2 kilos, right? Or less, we can kind of rewrite this portion to solve part B. Look, let's get some space here. So the smallest number of coins so that Roscoe can drop and the parachute not fail. So now we're only dealing with gold coins. So I'm just going to take this piece out, and I'm only going to work with that. I'm going to say, okay, well, I know that my gold situation is 22 minus 1/3 x. And we established if me and Roscoe are 88 and the parachute can only hold 90, there's only 2 kilos to give. So I know that whatever happens here with the gold, it needs to be smaller than, or again, exactly the same as 2 kilos. Okay, so we're just kind of taking that piece out to help us do some simpler math. Okay, so at this point, we just do some algebra. We subtract 22 from both sides. If I subtracted 22 from both sides, I can write that for you. I'm going to get left with negative 1/3 x, okay, is less than or equal to negative 20. Okay, so far so good. Now we want to get rid of this negative 1/3. To do the opposite of fractions, there's a nice trick. So you could technically divide both sides by negative 1/3. It would cancel. But you can also look at it a different way because dividing a fraction by a fraction, sometimes we get a little confused. But if we think about it, I could just multiply this side by negative 3, and I can write it as a fraction. Let me just draw a line here so you know where we're at. Right? So I put negative 3 over 1 times negative 1/3. And over here, I also just multiply by negative 3. And if you want to put it over 1 and over 1, because negative 3 over 1 is the same as negative 3, no problem. So these are going to cancel, okay? So negative 3 times negative 1/3, that just cancels out, so we get x. But here's the big rule with inequalities. With inequalities, if you multiply both sides by a negative or you divide both sides by a negative, you gotta flip this inequality sign. So actually I'm going to say x, or my number of coins, has to be bigger than or the same as, and negative 20 times negative 3 is positive 60. Okay? So the smallest number of coins Roscoe could drop, the smallest number I could drop, or he could drop, is 60 coins. Now, if he wants to drop 61 and be extra safe, that's great work, Roscoe. But hypothetically, by just dropping 60, we should be okay. And so then we have a really interesting question. Okay, well, how many gold coins can Roscoe keep? That's interesting. So it's looking at the other way. So if we want to know what he can keep, we need to know the total of coins he had. And we could really figure this out a lot of different ways. And, you know, why not just go the simplest way, right? If I know Roscoe had 22 kilos worth of coins, and I know each coin is 1/3, I can just divide 22 by 1/3. What a great chance for us to show that we understand that dividing is the same as multiplying by the reciprocal and vice versa. So this is really the same as just saying 22 times 3. If you flip that, you know, the reciprocal of 1/3 is 3/1, which is 3. 22 times 3 is 66. So we know if he must drop 60 coins, and he has 66, well then you know how many does he have left? Well, 66 minus 60 is 6 coins. So, sorry Roscoe, you only get to keep 6. The good news is Roscoe won't fall to his doom. And also, if you think about it, maybe he can just pick those coins up off the ground after he lands safely, right? Okay, what a fun problem, man. Good job and good work. As always, go ahead and subscribe if you want to be notified when I make more amazing story problems just for you. And if there's a story problem you want to read or something you need to work on or some characters you want me to write about, I'm happy to do it. Just leave a comment below and I'll make it happen. Thanks. Bye.